Welcome to the Teachers module of Flipped Classroom program. Today we'll discuss about the classroom plan for chapter 9 of class 9, Force and Laws of Motion. Start the class with making a joke. Once upon a time, when Sir Isaac Newton was sitting, a cow came and stood in front of him, and Newton wondered why was the cow not moving. So he realized that unless an external force was applied on the cow, it won't move. So Newton gave cow a kick. Now when Newton gave a kick, cow said ma, and Newton realized force is equal to ma, that is ma. Now the cow kicked Newton back, which made Sir Isaac Newton realize that every action has its equal and opposite reaction. During the story, make sure students are repeating the laws of motion with you. If someone isn't able to repeat, ask him if he watched the videos. And if not, ask the student to make a note of these laws as it would be required to solve today's problems in the class. Now, repeat all the 3 laws, or you can point random students in the class to repeat it for you. This whole process should take around 10 minutes of your time in the class. Next step is to make students intrigued. The best way is to challenge their thinking. Ask students what the unit of measuring time is. Answer would be second. Do the same for weight and length. Get various units of these quantities answered by students. Ask the unit of measuring force. The answer would be Newton. Now ask them how much do they weigh. They would answer 40 to 50 kgs. Ask them if anyone thinks they weigh 500 kgs. They would say no. Show them your palm and ask them the length of it. They may answer 15 to 20 centimeters. Ask them if anyone thinks it is 200 centimeters. Now, give them a time duration of 5 seconds by saying start and stop. Ask them the time. Answer would be 5 seconds. Now, ask a student to press your hand. Ask him how much force is he applying. Give him the options as 10, 100 and 1000 newtons. They'll be unsure. Now you ask them how we can measure force. Ask them with which instrument do we measure time, weight and length. Bring the spring balance and ask them the job of this balance. Take their inputs and explain to them that when an object is put on the hook of this balance, the spring gets elongated due to the force of pull by earth, which in turn moves the hand on the dial. The force with which it pulls is mass into gravity. The number on the scale shows only mass. Hence, show them that if we were to measure force, we can do that with the spring balance. If the reading is 4 on the dial, the force you're applying will be 4 kgs into 9.8 meters per second square, approximately 40 Newton. Ask the students to try the forces and get a feel of it. Come to the third law. Everyone will repeat every action has its equal and opposite reaction. Ask them if they have understood it. Then question them by asking if every action has its equal and opposite reaction, then they should cancel each other. For example, when you are pressing against the wall with the force say F, then the wall will also give a force F backwards. F and minus F will cancel and hence the total force on the wall should be 0. Which means wall shouldn't move, which actually is not moving in reality. So maybe our hypothesis is correct. Now when we press against the pen with the force F, the pen should also apply a force F against us. Hence F and minus F should cancel. Net force would be 0, which means pen shouldn't move. But it does move. Ask them why. Possible answers which they will give are pen's mass is less, so it can't give enough force to cancel. Counter this argument by saying that Newton said equal and opposite irrespective of the mass. Second, wall doesn't move because of friction. Counter by saying that there's friction for pen too. Third, they might say Newton was wrong. Tell them maybe they are wrong and ask them to dig deeper. The answer lies in the bodies on which action and reaction forces act. When we press against the pen with force F, we apply a force F on the pen, and the pen applies force F on our finger. So, 2 forces are being applied on 2 different bodies and hence cannot be cancelled. So why does the wall not move? Well, ask the students and get it out of them that wall is held again from the bottom, which creates enough friction that humans can't move it, but bulldozers can. You can do the following problems on this chapter.